Alright, today we are going to have two different videos. This first video is coming from me to help explain how we find the formula for area of a circle. The second video is also going to explain that, but it's going to just kind of sum up what we're talking about here. It just shows it in a slightly different way to help explain it. So I can't have you do this explore activity at home, so I'm just going to, you can try it with me if you want to pause and cut out a circle and follow the steps with us, you can. However, this is what we would have done in class, and so I just want to walk you through it so you can understand how we get the area formula for a circle. So it's going to build off of what we know from circumference. So what we would have done in class is I would have given you a circle, you would have cut out the circle. Then we would have folded the circle smaller and smaller, right? Fold in half, fourths, and then one more time, okay? And then we would have opened it back up and we would have shaded in half of it. And then we would have cut the triangles that we have from our circle. And what you can do is when you take your triangle pieces from your circle, you can actually form them together to create this parallelogram. So I know this is going to take some visualizing on your part, and I know it's hard not having the pieces in front of you. Again, if you want to pause and try this, go ahead. But it's still going to help you see why we get the formula that we do get for this. So we have half shaded in just so that we can help see which piece is which. So I'm going to go to the next screen just so I can show you a little more specifically. So when we do area of any shape, not just parallelograms, but any shape at all, it's always that base times height. You might say it as length times width, but it's always coming back to that original idea of you take the base times the height to get the area, okay? So we're talking about that with a parallelogram because we just showed that we can take the exact same amount of space that was in this circle, and if we rearrange those pieces, it can create a parallelogram. So let's look at what that would mean in relation to our circle. So how do you think the height of the parallelogram relates to the circle? So this is just a thinking question. So if I look at the base of the parallelogram here, and I know they're rounded out, I get that. We could always straighten it and it would still be the same amount of space as our circle. So if we look at our base here, see why we shaded them differently? Because then you can see how it matches up with these blue pieces or these shaded in pieces, just like we did here. So if I look at the base, it is only half of the circumference of my entire circle. Okay, so base is going to be half of the circumference. I'm just going to write that on here real quick for you. So half of C. And the height, if you look at each height, if I go from straight from top to bottom of this parallelogram, remember straight perpendicular, remember no matter where I start with this circle, center to out, it's always going to be the radius, right? I can pick any spot on the edge of the circle as long as it's straight to that center, then it's going to be that radius. Well, that's what's happening when we look at our height of our parallelogram. So the height is going to be the same as the radius of the circle. Okay, that's what those pieces are when we look at these shapes, right? These are they're a different shape, but they mean the same thing. They have the same space, so we're relating them to each other. And so we're noticing at the base of the parallelogram, because we know for a parallelogram it's base times height for the area. Well, the base of the parallelogram is same as half the circumference, and then the height is the same as the radius of the circle. Okay, so we're going to use that idea to come up with our formula. So I want to talk real quick about this base here. Okay, so this is half the circumference. Well, if you remember, circumference, we have two different formulas, one of which was the 2 pi r for circumference. Well, if I take half of that, which is dividing by 2, that's going to cancel these 2's out because it's 2 divided by 2 is just going to leave you with 1, right? So those end up canceling out. So half the circumference would just be this pi r. That's how we end up with this right here. So half of the circumference is the same as pi r because the entire circumference is 2 pi r. Okay? So let me go on to one more thing here. So if we try to make sense of this, we know that the area of a parallelogram is just base times height. Well, that's really the same idea as area of circle, The only difference is how we represent this base and height. It's not just as simple as two measurements. So let's take a look at what we just discovered. So we know, I'll just kind of show you all and I'll talk through it, okay? We know that the base of the circle, or of our parallelogram, was the same as half the circumference, which is pi r. So what we did is we took base and we substituted what we know the base of our parallelogram is. We know that that's pi r because it's half the circumference. So all we did was substitute that in. We also knew that the height was the same as the radius of the circle. So we just substituted the radius in for our height. Now we can simplify that by combining like terms, since this has an r times another, because really this is all multiplication, right? It's really saying pi times r times r. Well, instead of saying it that way, we could say pi r squared, because we're taking r times r to get r squared, and then we just multiply it by the pi. So we end up with pi r squared. That is our, let me rearrange this. That is our formula for, for area of a circle, okay? Now I know that's a little confusing, so there's one more video for you to watch to help explain it. It's going through similarly to what I did, but it just helps remind you how we got these pieces. So this is that formula for a circle, for the area of a circle built off of circumference of a circle. Go ahead and watch the next video.